I think it's recording, right?
Yeah, yeah, okay, yeah.
Yeah. Yeah, 1 second. Okay, I think we can start. So I will share my screen, or Dmitry, maybe you.
I have only little presentation about Apache Spark, and if you don't tell about Apache Spark, I can start from Apache Spark.
Uh, yeah, I mentioned in about Apache Spark, but you can
Okay,
do your
yeah. If
presentation.
it overlap, not the problem.
Yeah.
So what we have about Apache Spark? Okay. Um, yeah, that's I also, because it was from another presentation, but the idea and the same I covered in the, I think, Model Zero about Python requirements, but just couple books that help you to learn Python, the Python crash course, and think Python, the like good one. This is a bit advanced book. It's big one I started but didn't finish. Yeah, what is Spark? Apache Spark and Databricks is basically Apache Spark is open source software, and the founders of Apache Spark, they created the company Databricks. So it's like and it has all tools that you're able to work with and build analytics solution. But if you just look to Apache Spark, because it's a core, this is software that you can install on your virtual machine, on your local machine, or and you can build the cluster. The idea that it can read the data, so it can connect to database with JDBC connections. You can run Python and connect the different APIs, or you can read files in local storage, HDFS, or in the cloud. You can read it. As soon as you read, you can start transform and do something with the data. And then after you finish reading transformation, you can write it back. You can write it as a files. Usually it's lakehouse, where you can just simple data lake, or you can have lakehouse with iceberg, hoodie, or delta. And if you want, you can use the metadata. Um, Traditionally, it was Hive. Now it's Unity catalog in Databricks. So it's kind of just the catalog with the tables. And you need it to feel similar way like you query database, because you can expand, you can see a list of the tables, and you can query those tables with the SQL. So this is how usually BI tools connecting to Apache Spark or Databricks, or you can give access to analysts who comfortable to do with the SQL. And Spark support also many languages like SQL, Python, Scala, C Sharp, and I think many other programming languages. Right now, it's available version 4.1 for the Spark. So why we need Spark? Um, for me, it's usually in the way I prefer work with the more or less traditional data warehouse approach, something like Snowflake. And even right now in Snowflake, you have Snowpark. It feels like Spark, where you can have notebooks and write PySpark, but it's actually all one compute engine. And I think the Snowpark convert your PySpark into SQL and submit. But traditionally, it was for me, okay, I can use Redshift data warehouse, and I have some use cases. I'm not able to process lots of raw data from the data lake or S3, and then I can use Spark to process big volume of data and save aggregated result into my Redshift cluster or Parquet. So it's a kind of like complementary use case. In other options, some teams and some companies, they don't use any data warehouse product. They go straight to data lake. So it means you have data in S3 or in any other HDFS, any other storage, and usually in Parquet format. And Spark is a thing that you write the queries, it query the data, it transform data, save data. So you're using it for querying data and for ETL. So it's your compute power. Or you can do not data lake, you can do lakehouse. The only difference data lake lakehouse is the table format, how you save and how you define tables and data in storage. There is also use case for streaming. Initially, it was Spark structure streaming. It's like micro batch. So assuming you have tools like Kafka or Kinesis or Event Hub that sending events in real time, Spark can listen them. And it's like, imagine you get coming events, like, I don't know, for example, JSON files non-stop, and Spark can take every file, process it, and save in data lake. It also has the capabilities for running machine learning workloads because it has many libraries for the machine learning, and you can build the whole machine learning things. Even it's can process not only text data or structure and semi-structured data. It can also working with image data, sound data, so it can do many different things. And obviously now it can work with generative AI as well. The options to deploy Spark, you can run it on machine for free just to learn, but you need to make sure you install the Java virtual machine. So this is one downside of Spark. Then you have BigQueries. It usually job failing with something out of memory or memory spill. Those very common for Java applications. And for production use case, for example, I know in Russia, many companies who is doing analytics on premise, they can have a Hadoop cluster, and they need Hadoop cluster mostly for the storage because Hadoop has storage like HDFS, or you can use instead of Hadoop Minio that mimic S3 block storage. So this is a kind like you can have your data lake Spark and Hadoop or like any other alternative in the cloud. You can run even cluster in Docker, or you can use the managed Spark. And Databricks is #1 for this. Alternative like Amazon Glue and Synapse, I will cover later in the Surfalytics them. They more like using Spark, but for example, for ETL, not for end-to-end data lake. So it's more like just compute that you have. And obviously you can deploy Spark in Kubernetes if you want to have open source Spark in your cloud or on-premise. There's the books. This book, probably the most recent one, it's outdated still, but it's not big book. It is free, Learning Spark V2, and it's covering and everything in details. Now what we have, so Google, because before Spark, there was like traditional, even before Hadoop, there was traditional data warehouse, and then Google started to work on the system basically because they have lots of data and their traditional database couldn't scale enough. So that's why they created new solutions and papers. First week, they created Google File Systems. I think the idea was that imagine you have many computers. Every computer has own hard drive. The idea of Google File Systems that you can connect those computers together, and it feels logically like you have one huge hard drive that consists from many physical machines. So, and I think this was like game changer. And then they created MapReduce. So MapReduce, it's the how you process the data, because Your physically data is scattered across many machines, and map and reduce, it's basically two-step operation. First, map, every computer will query own data, and then the pass result to the master node, and the operation reduce will happen. So it's like take result from each computer and will consolidate to the final output. And also they create a paper about BigTable, and I think BigQuery is basically using this kind of technology, like BigTable, and those the most popular white papers related to this. So interesting, you can learn more about them. So what they do? So Google File System provide fault-tolerant distributed file systems across many commodity hardware servers in a cluster form. This is what I covered. BigTable offered scalable storage of structured data across Google File System. So I think BigTable is kind of like on top of Google File Systems. And MapReduce introduced new programming project based on functional programming for large-scale processing of data distributed over Google File Systems in BigTable. So everything makes sense. And then after Google, Yahoo took over, and they take their Google File Systems and create Hadoop file systems. And then in 2006 made it open source with Apache Foundation. What Hadoop is doing, so, and this is what still, especially in Russia, many companies still on doing this thing. Your Hadoop, you have data storing there, you submit MapReduce jobs, it can read the files, and it has intermediate steps. So where it's a kind of like starting saving intermediate results, writing to the hard drive, that is HDD, and then it's again reading till final result. So it has many challenges. It's hard to administrate, hard to develop, long time to start a job, batch processing, and especially then MapReduce job writing and reading from the disk. This is very slow operations because you have HDD disk, and writing and reading from this, it's always very, very slow. And before the SQL even wasn't the case, I think the first SQL approach was the Hive. Then it gives you, and Impala give you this idea that you can query. Hard to optimize queries, and data format wasn't that good. And then, yeah, there are some new tools available, Apache Hive, Storm, Impala, Drill, Mahout, and like, yeah, I only think work with Impala and Hive. Mostly, I think Storm was for streaming. But yeah, challenge still there. Simple things should be simple, complex things should be possible. Yeah, so it's Hadoop work, but even for small tasks, it always takes a lot of time. And it was not that reliable. And then in Berkeley Lab, the team was working on solution to make it faster. And then it came up with Apache Spark. So, and it was like up to 20 times faster. And in 2013, they created Databricks and released Apache Spark 1. The biggest advantage was that Apache Spark can do all the operations in memory. So if here MapReduce need to kind of like save result and you need to wait, Apache Spark like just reading, skipping everything, do all the operations in memory and save a result. But it still can use compute of Hadoop and Hadoop file system to read the data, because Apache Spark doesn't have any storage. It's only compute. And initially it was you can like plug in for your Hadoop there. The same Hadoop clusters, you can install Apache Spark. Yeah, what's Apache Spark? Speed, ease of use, modularity, extensibility. The speed is you basically have hardware with CPUs and memory, and you have clusters, and you can start from single cluster, or even just single machine, and then you can scale up. But usually you have the worker nodes and master node. It utilizes directed acyclic graph. You probably heard about this from Airflow and dbt. So this is how, if you submit one huge job, it's starting to split this job into stages, into tasks, and they're all connected in the DAG. And also, Databricks contribute a lot into performance in the way how you can work and how the execution plan is creating. For example, engine Tungsten, this is one way of creating efficient plan. Then you submit the query. I think another thing they did is Photon. It's like SQL engine that works with the SQL queries especially. Under the Spark, because you can work with SQL, Scala, PySpark, and you mostly works with data frames, but then you even work with data frames, they converted to resilient distributed data set. So this is kind of like initial data structure, because data frames released later before it was resilient distributed data set. And if you check example, how Spark can work with RTD, so it's not that friendly as a PySpark. And also in Spark, you have two operations. You have transformations and actions. Transformations operation, which you do an operation against existing RDD, and it will produce new RDD. Or it could be the same applicable for DataFrame. And actions, operations that return the result of computing in RDD. And the thing is in the Spark, especially for when you develop in Spark, it's important to know that assuming you write the query, and if you do just the transformations and you don't have any actions, action could be, I think, filter or printing result, showing result, or writing. This is action. But if you just write the query transformation and you submit, nothing happened because till you don't show any action operation, the Spark won't read the physical data, won't run any query. As a result, you can keep going to building your queries, joins, transformations, and then you click submit, the only plan will generate, but it won't execute it till you bring any actions. And actions, it could be, for example, you want to save result in the table, or you want to print the output. And by modularity, they mean that you can do many things. So starting from SQL data frames and data sets. Data sets, they work with Scala only. Spark structure streaming, machine learning libraries, or graph databases. And I think now you have way more things. And Spark can work and connect with like pretty anything. Unified analytics means that idea that now machine learning team, data science team, data analysts, and data engineers, they can work together into single platform because you, for example, in a Databricks, especially you have notebooks, you can write SQL, Python, you can run machine learning projects and so on. This is key components of Apache Spark, Spark SQL data frames, streaming, machine learning, graph, and yeah, there's the languages, but now it's way more. Example of Spark SQL. For example, in this example, we can read a file that we store in S3. And in the same command, we create the view, temporary view that will register it in our catalog or Hive Metastore or Unity. And then we can execute the SQL that same as maybe now it's even better, but it's just typical SQL. This example of machine learning, like you can import any machine learning library from the Spark itself, or you can bring like TensorFlow or anything else. This example of structure streaming, the graphics, and Apache Spark distributed execution. So because Spark itself consists from multiple things, like your end-to-end program that you create in the Spark used to call Spark applications. And the Spark driver, it's manage the whole process. The Spark executor, it's I think that execute the code. The Spark session. So especially then you working with Databricks, all of these, you don't know this. It's kind of like hiding under hood. But if you use open source Spark, all of these important, like executor, session, to start like submit the commands, cluster management, job, stage, task. So this is how Spark splitting, like then you submit your huge query or pipeline or ETL job. It's actually doing all of this. Distribute data in partitions because it's still distributed thing. Uh, it's important like how you can store and partition your data to read efficiently and save efficiently. And there are many configurations in Spark. I think even in Databricks, you still can decide what is the file size if you say write it to Parquet, how many files right you want to have, uh, partition, how you want to partition data, and so on and so on. And Databricks, especially, it works in the way that it's releasing new feature to give you feeling of Databricks similar to Snowflake. So in Snowflake, the benefit then you do something in Snowflake, you don't care about partitions, you don't care about size of the files, anything. You just write the SQL query, create the tables, transform the data. So in the Spark, special Databricks, moving into this direction as well. The idea to make it efficient and convenient, but overall Spark, they more complicated than traditional data warehouse. Even if you just take Redshift, in Redshift you have sorting key and distribution key and data compression style. That's it, like three parameters that you control. But in Spark, it has so many configuration options. You need to decide if the cluster size, you need to think how many clusters, what's their size, how many CPU, what's the operational memory, how you want to configure your Spark, how many files or what kind of file you want to save. So many configurations, so it's quite complicated. And obviously Databricks is good because it's hiding many things, especially now, probably Vlad will show us serverless clusters. It's then you don't need to think about what kind of and size of cluster you need to create. And it's if you have good partitions and everything, you will have efficient parallelism. So because Spark executor, each will work on own portion of the data, maybe reading own partition or own data files. That's why it's important to know size of the file, number of the files to achieve the parallelism. If you, it might be, you have the cluster of Spark with many nodes, but you just have one huge file. Obviously, only one executor will read this file. They're not able to do it in parallel. Yeah, that's it for me. Just very brief about Apache Spark, and it's good to know. Yeah. What's the question?
Uh, could you tell please about the difference between Databricks or Apache Spark engine comparing to Snowflake engine or BigQuery engine, for example? Uh, yeah.
Yeah, that's so I think can say type Snowflake, what did they show us? Or is so what is Snowflake? So first, on the simple example, Amazon Redshift. So what is Redshift? Redshift, I know it's size good enough, but Redshift, this is your cluster that consists from multiple nodes. Now, or maybe Redshift is slightly different, but before you have multiple nodes. It's same as a green plan or I don't know, Oracle the Teradata. You have multiple nodes and you have one leader node. So by node, it's actual virtual machine or like physical server. In Redshift, obviously, it's virtual machine. In green plan, it could be virtual machine or server. But you have several virtual machine. They're all the same like size and types. but one of them serves as a leader node, and another one is a workers. Then you submit the query. The query leader node creates the plan and sending execution steps to the compute nodes. The compute nodes, this is your physical, or not physical, like virtual machine, but it has own CPU, RAM, and hard drive. So the data storing in hard drive, but it's splitted. If you have 1 terabyte of data and you have 2 nodes, obviously it will store around like 500 gigabyte here and 500 gigabyte here. So, and then you're sending query, it's starting, each of them starting scanning their data. And that's why it's important to think about distribution style to control how evenly your data will be shared among virtual machines, because it's separate machine. Your goal is to achieve the parallelism, like this MPP idea. But the Redshift, the data is not storing in one single place. It's storing, each machine has own piece of data. And then with distribution style, you can decide, oh, I can copy data among all nodes, or I can use the ID to evenly split it among them. So this is architecture of Redshift. Is this clear?
Yes. Yeah.
Okay. That's the most simple example. Then if we talk about Snowflake, on the other hand, Snowflake it kind of was main competitor for Redshift. What they did, they call them data warehouse, but it's not the data warehouse. It's actually more like lakehouse, but it's like a closed lakehouse. So what they have, they said, okay, we will use storage, maybe S3, but it's only in the cloud, right? So we will take AWS example. We'll use S3 as a storage. So we will store all the data in S3. So it means we don't have the situation like here, then you split the storage between physical machines or HDFS, right? It's basically a bunch of disk that's storing the data. Of course, it has some kind of replications, but the idea is kind of like data not in one place. So here, you store all the data together in S3, and then you have the compute engine. So here in Teradata, the compute engine is a kind like you have many virtual machines is a cluster, but in nutshell, you have just one compute, one single machine, and you have 100 queries. They will come to leader node and they will stack in the queue. So, and you decide how many concurrency, and biggest problem for Redshift was the concurrency, how many concurrent queries you can submit in Redshift. That was the biggest problem. And then okay, if it's too slow, we maybe need to increase the size of our Redshift. Instead of 2 nodes, let's add 4 nodes. But then you add 4 nodes, you automatically get like twice bigger storage. You get more CPUs, more memories, but your bottleneck was only compute. Like you actually didn't care about storage, but you pay for both in anyway, because you just, oh yeah, just going bigger. And you can choose you can scale up, you can get bigger, still 2 nodes, but bigger, or you can scale, I think how it goes, like horizontal scale, that you can add more nodes the same size. So in Redshift, they did completely different. So they don't have any problem with storage. It's kind of unlimited at S3. But they also say, we will have dedicated clusters. And it's imagine you have multiple Redshift clusters. You can have multiple Redshift clusters that can access the same data from many places. So in Redshift, it's not possible. It's kind of like access itself data. In Greenplan is not possible and so on. But in Snowflake, you have many compute clusters and you can decide their size, but they all will reading the same storage because it's NS3. So technically, it's act like data lakehouse, data lake that you split, because in Redshift architecture also calling sharing nothing, because you have individual virtual machine and they have own resources. It means sharing nothing, like they're not sharing anything at all. like they have own CPU, memory, and storage. That why it's called sharing nothing, and that's why it's called massive parallel processing MPP, because they can work in parallel. So what Snowflake telling us, you have sharing everything. Then we talk about storage, because storage is sharing for every compute cluster, but the compute is still sharing nothing, because you have dedicated compute, and warehouses, you can say create one warehouse for IT, one for ETL, one for marketing, and so on and so on. And you can just define the size. So you have unlimited capabilities to submit queries with multiple warehouses against your sharing everything storage. That's the beauty of Snowflake. And then, yeah, it's using SQL as a primary interface to read and write terabytes of data. And obviously now they have Snowpark, notebooks. They even added for machine learning, like model registry. They have Streamlit for web application. So they even have the recently, I think they call Snowflake Apache NiFi. So Apache NiFi was the open source ETL tools, but now Snowflake has the tools that calls OpenFlow. So it's a kind of like Fivetran inside Snowflake. So it has a bunch of connectors. So the Snowflake is a kind of like platform that can do many things. Not just, we used to think its main is the data warehouse, but it's now can ingest the data. It can work with streaming. You can build the web app applications with Streamlit. You can host your machine learning models. It has a generative AI capabilities and so on. And Databricks, on the other hand, the same idea. You have storage in the cloud, all the same, but instead of virtual warehouses, you have Spark. You can call it the same, like warehouses, or it just compute. So it's a kind, you have the same. So it looks like Databricks and Snowflake, they're actually way more common than Redshift and Snowflake. I think Snowflake was the called data warehouse just in sake of marketing, because everyone knows what's data warehouse, and that's why, and everyone thinks data warehouse is the SQL, and this is what Snowflake. You have the interface, you submit the SQLs. That's it. But yeah, from architecture perspective, they more like lakehouse, and keyword lakehouse data lake. It's the data format, because data lake only Parquet. Lakehouse is the Parquet and your log, iceberg log, delta log. So it's additional information, metadata about what data you're storing. So, and this is about, but what's about BigQuery? And BigQuery, Nikita, I think you know more than we.
Yeah, I think it's similar to Snowflake.
Yes, but I think what in BigQuery feels differently for everyone
You don't
is,
need to manage compute.
yeah, you don't manage. So in BigQuery, you don't have abstraction for how many like warehouses or how many clusters you have. So the data is still like this one. So, and I think data in BigQuery more like Snowflake, because it's storing in the storage, like in Google Storage, but in their own format. So BigQuery can access, for example, Parquet data from the same as Snowflake can access like Parquet data. There's open formats as external tables, but initial idea that Snowflake and BigQuery, they have they're storing data, their proprietary thing. In Snowflake, you still control the size of the warehouse and number of the warehouses, the same as the Spark. But in BigQuery, you just have the interface where it's more for you, it's like some kind of API where you submit your queries and you don't control the scale. I think you can, because probably BigQuery, you pay more like, I don't know, credits or whatever. So it's, you can set some threshold how it's scalable and how it is I don't know how to say. But basically, you just submit the queries. That's it. You don't control anything. There are, I think, it using some kind like slots, how much slots it spent per query. So it instantly tells you how much uh, how much money it will cost to run the query. Yeah, but BigQuery feels very different. And there are still techniques how to optimize the BigQuery. Yeah, but yeah, I don't know.
Yeah,
But
so the difference with Snowflake, that Snowflake you can manage warehouses, and in Snowflake that you pay for like the time these warehouses and
yes.
the like volume of these warehouses. In BigQuery, you are paying for the amount of data that will be processed. And BigQuery assess it automatically, and you can see like preliminary price before like running the query.
Mhm.
Yeah, got it. Yeah, thank you for explanation.
Yeah, I think that's very important to understand because this is kind of like foundational thing for the system design because you don't have many products for the storage and they don't have many difference. Yeah. Okay. Vlad, now your turn. I
Yes. Thank you, Dmitry, for brief introduction. I will share my screen.
okay. I can find where's my button to cancel the screen sharing. Maybe you can
I
cancel it
think
for me.
I will start
Oh, okay, perfect.
sharing, and yeah, I think. Can you see my screen? Uh, so I suppose you can see my screen, right?
Yes. Yes.
Okay, yeah, thank you. Maybe it will make sense to split this session into two different parts because Dmitry told a lot about Spark. And I will tell about Databricks specifically, and I will jump between my file in Git repo. You can see it into Discord channel, and between presentation I created recently. Thank you, Nikita, for good source of creating presentations. So yeah, I think we can start. So basically, Databricks is a cloud platform for data and machine learning. Um, it runs on top of the Apache Spark, as Dmitry told, and we will also speak about Spark in several minutes. Databricks is more like compute, not storage, because you data can be located in S3, in Azure, or DBFS. It's like their own file system. Um, Databricks run jobs. And the main purpose of Databricks is to collect everything in one place. And you get one place for notebooks, schedule jobs, governance, ETL, analytics, and every other things. On this page, you can see it's like an infrastructure. So we have some kind of sources that can be in our company. And then Databricks basically provides us with a solution how to transform this information, this data, and get the final results. Yeah, about the Databricks ecosystems. It doesn't live alone. It needs the cloud. It could be AWS, Azure, Google, and GCP for for VPC storage and identity. And under the hood, it uses Spark, as Dmitry told. We also have data lakes for tables. Data lakes are some kind of format for Databricks, it has Parquet, time travel, and ACID. We have Unity catalog for one catalog and permissions. It's like metadata about your information, your data. And there is also a DBFS, their internal file system, and GitHub, of course, we can use for version control and um, for working from different sites. Yeah, why Databricks is so useful? I think it has one good pros because it's one platform. So we have ETL, streaming, SQL without jumping between tools. And of course, we can scale because Spark scales out. We can add workers. I will tell about workers a bit later. If we need more power, we can add more these workers. We also have some flexibility with clusters. We can start these clusters, we can stop them, we can manage these clusters, but we can also use serverless to use, and we don't need to set up anything related to virtual machines. Also, Unity catalog is one place for tables, and it's very convenient, so we will use the Unity catalog later in our small project here. And yeah, this platform, I mean, Databricks was created specifically for clouds, basically. Of course, it can use on-premises data, but the major part, it's really good in integration with AWS in terms of S3 buckets and ADLS in terms of Azure. So let me check here. Yeah, so these slides pretty much duplicate the information from the Git repo. And yeah, we have some information related to Apache Spark and PySpark in brief. So the difference between these two definitions is Spark, it's the engine under Databricks, as Dmitry told, and PySpark is the Python API we can use, and for example, we can use different languages, like we can use SQL in Spark, in PySpark, so we can stay in one in one point. We can stay in Python, and Spark does every work related with SQL just to transform everything. So let me check. Yeah, I think Dmitry talked about the Spark. We also have some information here about query planning. Query planning is another big topic. I actually don't want to touch it too deep, but what I can say here, so it's a good feature that built in Databricks. So when we build a data frame or run SQL Spark doesn't execute it immediately. It first builds a logical plan and then the physical plan. The physical plan is some kind of how this work will be split into different workers. One second. Workspace and regarding the workspace, I have created one just to show anything that can be related with this topic, and we will do some kind of small project here. And also the main part in the Databricks is clusters. So let me show. Oh yeah, one more important thing. Here we have some kind of split. We have some parts in Databricks that we can control and manage, and the other one, the Databricks side, can change, and we can't do anything with this. And this table shows what part of Databricks we can manage. For example, we will set up VPC subnets or security groups. We will, yeah, so the major part related with the networking side. And also the data we have, it is stored in clouds. So yeah, as I said, Databricks is just a thing that will help us to transform this data. So yeah, let's check the Databricks interface. So the UI is pretty convenient here. I use the free version for this demo, and here in free version we have only serverless compute. So we don't need to set up any settings related to clusters. We just have the serverless, and we can work with this when we need to perform some transformation. But I wanted to pay your attention that we have different types of clusters. So the cluster is basically a set of VMs that run Sparks. Driver node is some kind of the boss. It coordinates tasks and split it between different workers. And worker nodes that do all the work related to transformation and reading and writing. So we have several cluster types, and for every purpose we can use different clusters. For example, we have all-purpose clusters. They're more common for interactive work, like notebooks, ad hoc tasks, and it can be managed by us. We can create and deprecate these clusters. Also, we have a job cluster. This job cluster is creating specifically for a job. It's very convenient when we need to understand that we have the capability for this job, and this job is some kind of predictable, and we can use the job cluster to start and terminate these jobs. In terms of costs, it's efficient, but in terms of auto-scaling, it's not so flexible. We also have cluster pools. It's like a pool of warm nodes. It needs less time to start up, but it also has some limitations, like it may be the situation when we don't have enough clusters in this pool, and because of that your job cannot start. This is an example of all-purpose cluster. So if you can see here, we have some kind of serverless cluster. We see only the cluster size, and scaling is also limited. It's maximum one worker. And if we creating, for example, an all-purpose cluster or a job cluster, we can set up a configuration. So what configuration can it be? Here on this, oh no, go back. I hope it can. Second. Yeah, I think it's a bit closer. So here we will choose the Databricks runtime. It's some kind of preset in terms of which Apache Spark and Scala we will use. Also, we can use preferred worker type. And in this example, it's a pretty big one. So it has 61 gigabyte memory and 8 cores. And also, as I said, we have one driver node. And here we can specify the number of workers. In this case, we have minimum 2 and maximum 50 workers. And also we have some kind of auto scaling. In case our job requires more power, we can click on this option, and this will give us an opportunity to increase the number of workers automatically. So we don't need to do it by our hands. And also another pros from the cluster that we can set up manually is additional Spark settings. You can pass extra Spark and Hadoop options to the cluster, and it will help some kind of in terms of performance. And for this specific screenshot, we have some kind of settings. So there are a lot of different settings, and this is just an example. For here, for example, we have cache size. We can adjust cache size. We can enable glue table cache. We also can set up restrict cluster to SQL only access, etc. So there are a lot of different settings, and it gives a lot of flexibility to company, to especially for big companies that who needs to fine tuning their performance. And also, as I said, we have serverless cluster, and serverless you just don't need to do anything. You will just create serverless, put some small settings, and it will work as it is. Serverless also runs starts much faster than all purpose or job clusters, and this is another good side regarding the serverless. And we also have some kind of scenarios and recommendations which cluster we can use. For example, if we are in development, we can use all-purpose cluster or serverless. Depends on your work. In production, it is recommended to use job clusters. If the job is predictable, we need the amount of data, we need the operations that will perform in this job. And in this case, job cluster is ideal options for us. But we also can use serverless. And For example, if in production we have many short jobs, we can, as I said, grab some compute from cluster pools, or we can use serverless again. Recently, serverless became much popular than other types of clusters. Maybe in terms of cost efficiency, and the serverless cluster can rapidly start and perform. So we also have, it was about compute. We also have some kind of jobs and pipelines here in Databricks, and it's pretty much similar to other tools. For example, Notebook. It's like an environment we run, and I will show the Notebook and other practical stuff later. We also have jobs. It's like a task. We can combine these jobs and create a pipeline. And we also can schedule jobs by using Databricks, or we can engage different tools like Airflow. If, for example, company use this tool and it's more convenient to use this. So about the storages, we also have some different options here, but usually the main point is when we are creating Databricks workspace, we tie this workspace to a cloud. Usually it's AWS or Azure or GCP. And for storage, we use external and customer managed clouds like S3 buckets or ADSL. We also have some kind of managed by Databricks storage. It's DBFS. Here in our practical work, we will use DBFS because it's the fastest way to show some examples. And we also have Unity catalog volumes, folders inside a Unity catalog for files. It's similar to DBFS, but it has some differences. Autoloader versus batch. In Databricks, we can use both. In our practice, we will use batch ingestion because we are not too big for streaming, but it's just to highlight that Databricks can use both these ways, and every of these path we can set up in Databricks. So let's try to dive a bit into Databricks and check some work here. 1 second. So let me see. Yeah, so it's some kind of small overview. We have some JSON file. We will put it into our bronze layer. Also, we will transfer this JSON file into Parquet. And then we will perform some kind of transformation, and we'll save this into gold layer as a delta table. And after that, we can use this for BI tools and for analytics, etc. So here are the steps. You can follow them later. I will try to show it briefly. So let me check 1 second. I think I can use I can use this one. Unity catalog. 1 second. How can I do it more? Yeah, so in our workspace we can attach a GitHub repo. I have already done this, and it gives us the opportunity to work in repositories, not in workspace. It's convenient.
Sorry, Vlad,
Yeah.
can you show?
Can you show us there is a GitHub repo? I mean, maybe open the tab with GitHub repo to show. And I think also recently I learned that in the past they call it repos. Now they call it Git folders. Then you integrate the external repo.
Yes. So here, let me.
But did you use GitHub?
Yes, I used GitHub.
So if you
Yes.
open GitHub in the new tab, so you'll see the right.
Yeah, 1 second. So here we have our workspace, and it's created automatically. So here we have repos. For now, it's empty,
But
but
do you need to create repo first in GitHub, or you don't need?
if you want to uh, connect your repo to
Oh, I see. You create the repo inside Databricks, but you're not actually connecting to any external repos.
yes, so it's created by default.
Yeah. But I mean, yeah, because I was thinking you actually already connected to GitHub, but you don't.
Yeah,
But
it was connected, but I don't know. For example, yeah, we also have the opportunity to create a Git folder. And if we click here, we have, yeah, that's mine. So we can paste our repo here and click on create Git folder.
yeah,
And now we have the same information we have in my repo.
yeah.
Where is
That's for people who used to work with DBT. So it's kind of like then you can create your feature branch, you can do something testing in a local environment, and then create pull requests and merge. So here, this happening inside Databricks Workspace Studio. That's the idea.
yes, so if I open my my repo which I used for this project. So yeah, for example, I worked in Cursor, and then I push every file I created into Git repository.
And are you able to run the notebooks in Cursor? Like, do you
Yeah,
connect the cluster?
in Cursor,
Yeah,
I didn't check it, so I don't think we can do that.
yeah. I know there is Databricks CLI thing, like token, and definitely I know that you can submit your single notebook to the cluster, but not sure about dependence on them. But yeah, just keep going. But
Yeah, so for example, I used to work with Databricks CLI from the terminal, but it was another project. I mean, it was in the company that doesn't matter. So here we have all the information we need, and we will try um, to check everything we can create based on our uh, yeah, based on our small project. Where is it? practice concept. Yeah. So we can use catalog. So catalog is basically the information, the field that we can see every source we have. And yeah, I have already created the volumes, and I have created some kind of volume. It calls first DBFS Surfalytics. I missed the letter. But here, the point is we can add the data and the file here. And yeah, I followed these steps and created another different folder for bronze.
Just
And
to
here, yeah.
uh, clarify here, I know that by default, when you start Databricks, it is connecting to DBFS. So this is a kind, it's still the same like external storage, but it's natively integrated with Databricks Workspace. And if you shut down your workspace, this DBFS will be dropped. I think also for Databricks applicable term manage resources, because when you create Databricks Workspace, it is your workspace. I mean, right now we only work inside Databricks Workspace free edition, and we have no idea about cloud infrastructure or anything behind this. But if you have AWS or, for example, Azure account, you can start the Databricks Workspace, and you will have resource like just you can click on it and open from Azure portal to here, and it will create Workspace is your resource, but it will create a bunch of managed resources for you that is managed by Databricks. It means if you shut down your Databricks, everything will go on, including DBFS and the storage. So, and that's why for production, often what you're doing, you create the workspace, and then you connect it external like S3 bucket or blob storage or Google storage to make sure if you shut down anything, like everything else will be leave. Yeah, but this volume, because I don't know, what is it? Was it there or you somehow added the cloud storage or it was already there? How
No,
does it work?
so this one I have created yesterday by myself, and these volumes it's like DBFS, but they're here. So if you shut down your workspace, I mean, if you delete your workspace, yeah, it will gone. But if you continue working with your workspace, it stays here and you can continue working. But yes, you're absolutely right. We usually in companies we use external clouds for storage, like S3 or ADSL, and every information stored there. So we use Databricks just to perform some transformations. And here, yeah, it's a bit silly example, but we're having this example just to show how it works in Databricks and just to highlight the high-level diagram. And yeah, so as I said yesterday, I have created this volume. So it managed by Databricks, and we can see the some kind of information here. But the point is we can use this storage for some small operations, temporary operations, and I created bronze folder and also folder input, and we can just click on upload to this volume, and we will get some data here. This is the first step. Also, we will use notebooks to read this information that we will have in this volume. We can create a new notebook by using this button, or we can go to our repo that we connected, and here we have notebooks that we can run and check how it will work. So let's check what it will show us. We can use it by cell. Also, here we have some kind of flexibility in terms of PySpark. We can use SQL, Scala, R, or Python to run our cells, but by default it's on Python. So we work with serverless, so we don't need time when it will warm up and start. And yeah, this is another pros from serverless.
And I would like to add about serverless. It feels like Databricks recommendation right now using serverless, because it all as a we discussed about this, it's always a pain to choose the right cluster size. It could be too small, too big, over expensive. You can services you can just right now, but I think at the same time it decreased number of issues, because you have a small clusters and your job failing, like you will create support ticket, and then you will find out that you need to scale up the cluster or tune something. The serverless is trying to solve all those problems, and you just hit some kind of endpoint that always available. You pay only for what you use. So the project they're right now working with Databricks, they use only serverless. They don't have any single cluster. They use serverless for everything.
Yes, I agree. It's very convenient, and it gives you much less pain related to tuning these clusters, and yeah, also different errors. And as I said, in all-purpose or different clusters, we have some kind of Spark configuration, and sometimes it breaks. And yeah, you need to put a lot of efforts to fix everything.
But
But
on the
serverless,
interview, everyone will ask you about not serverless cluster. So be prepared.
yes, yes. And also, yeah, I recently uh, changed from all-purpose cluster to serverless, because I was told that we need to do that throughout every job we have. And yeah, I think that's the case right now. We can use serverless, and we will use serverless more often. So here it's a pretty simple command. So we have input path. For example, here we specified our volume, but if we use external locations like S3, uh, it's pretty much the same. So we will use S3 path here. And we also define a bronze path, so it will be our destination path. So here we have yeah, some Spark commands that can read this JSON. It's a small JSON file, but the point is just to show how it works. And also here we have df show, so it shows what data we have here. And yeah, as you remember, this is a JSON file, and with this command we can write this file into transform it into Parquet and save it into our path we specified before. And in this step, we just verify that we can see that the data is the same, but for now it's not a JSON file, but the Parquet. And if we go to, oh, 1 second. If we go to our volume in catalog, we will see that after this performance, we will see volumes. Yeah, we can see bronze, and for now we have not only input, but also we have events, and oh yeah, there are several files already, and this is Parquet file. So next we can use this Parquet file to transform it a bit and save it into the gold layer. And yeah, as I said, we can open a new notebook, create new notebook, or we can just open our existing notebook. And here we can specify the path where we have this notebook. So yeah, let's run it. Yeah, pretty much the same. So we have path for our files. We have our destination folder, and also here we will read the Parquet file using Spark. So in Spark we have a lot of different functions that will help us to optimize every command we will do, and it's convenient that we can just put it into notebook, see outcomes, and do not pay a lot of attention on the black box under the Spark engine. So here we have a new format. We have a Delta format. It's some kind of table that it's frequently used in Databricks. And we also verify that we maybe do or don't do some performance, some transformation. But for now, we have our final, let's say, final file in our folder that was created before. So if we specify the path, we don't need to create these folders or files manually. It will be created automatically after we performance our commands. And here in events we have a Parquet file, but we also have a table that was created, and this table has data source delta that we specified, and here we can see some kind of information. We can check this information by selecting our clusters and check if we have something here. It's starting. We also have some kind of details and permissions, but in terms of permissions and different compliance and governance settings, it's not relevant right now because we just use an internal Databricks infrastructure and don't use any external sources. But definitely when you work with real data, you will need to get some permissions and connect your workspace to external sources like AWS or Azure. And yeah, so here we have an example of our data. We also can query this data by using this side menu. For example, we have SQL editor and we can create a new query. It's slow for some reason. So here we can specify, oh, it's already specified, but if you have a lot of different catalogs and schemas, you can specify it here and just select how our tables is called. Oh, it's gold events. Yeah. Select start from gold events, so we don't need to specify. We can, but if we choose this catalog and the specific schema, we can just paste the table name and run this query. And also we need to check the cluster that will be used for these queries. So yeah, that's pretty much all, I think. Maybe you have questions, you can ask and I will try to answer.
Yeah, I would like to start from Unity catalog. So it feels like in your case, then you start the cluster, Unity catalog was already deployed.
Yes, Unity catalog is managed by Databricks and it's created by default when we create a workspace.
Yeah. And can you explain what is Unity catalog?
Yes, it's like source. It's like a source of metadata that is related with your actual data. So it reads your S3 buckets and provides you information regarding the number of columns, type of columns. So it's more like a metadata catalog. Let me check if I have it here. I believe I mentioned it in my README file. Oh, let me check. Yeah, Unity catalog. Yeah, so it's a unified metadata catalog. So it's pretty much the database where we can see what do we have in all external resources, and we can use it to query, for example, using this way catalog schema table. So, for example, imagine if I have a lot of different catalogs here, not only workspace, but also like catalogs related with the project and different schemas. So here, for example, in queries, I could specify my query and check this table based on the Unity catalog.
Yeah, and I think it also gives you advantage because now I think what we can see in Unity catalog, you have a kind of like database schema table, and I think in Hive you have only two, like something like database table. So
Yeah, but for now we don't have option to use Hive. I think in new spaces, yeah, because it's legacy right now.
yeah, it's like, but if you running Apache Spark by itself, you have only Hive. The Unity catalog is also open source, so technically you can have it for your own purpose. But yeah,
Yeah.
I can show you quickly on Azure because I have Azure account, so I can show you how we can create Databricks workspace and what we have, like then it's creating, and what configuration options we have.
Yeah, you can share your screen, of course.
And Vlad, last time then I shared the screen. Did you see my screen? Because
Yes.
okay, because then you shared your screen, I didn't see it, and then I log in separately as a guest. Don't know why.
But I hope you saw my screen, right?
Yeah. I opened as a guest, join as a guest.
I see. Yeah, so you will share your screen?
Yeah.
Okay.
So that's the Azure account. And on AWS it's different because in Azure, Databricks is they call it Ring 1 service. So it means it is integrated into Azure and feels like any other Azure service. So you can find it Azure Databricks. So you can create workspace. You can choose resource group. You can choose any name. Azure Databricks. And maybe AWS. Pricing tier. Obviously, like this was, for example, role-based access control. That's Databricks got it after Unity catalog because now one of the benefits of Snowflake or any other database, you can control permissions, and that Sevek showed us you can control permissions on the table granularity and schema granularity, so you can define who can see what. And in Data Lake before, it wasn't the case. In Data Lake before it wasn't the case, and that's why they can like move to Unity catalog, and now you can control the permissions and everything. So work types, interesting. This is new configuration workspace type.
Yeah,
To
they
compute.
recently introduced it, and I even didn't have time to check everything. But yeah, this is another point that serverless becomes more and more popular.
Yeah, and but I will use the hybrid to show you like options because for the challenge with serverless and everything, it's harder to understand how the things works. But if you understand how it works, like, oh, you have compute cluster with Spark and you can write the code. So even if you used to work with Apache Spark from your local machine, it will be easy for you to understand Databricks. Versus you just, oh, you open Databricks workspace, everything serverless, everything managed, and you just like monkey submit the queries. You're not able to understand what's happening.
Yeah, and also they have some issues with this serverless workspace, so it's like maybe already released, but it's
Yeah.
in beta testing because I see a lot of tickets.
Yeah. And the biggest challenge, at least in Asia, even in I think the very first project for Surfalytics, we tried to create Databricks workspace with no public IP for workspace. So it means this URL that you log into Databricks, it's not available to the internet, and then you need have some kind like VPN or basically some kind tunnel to be able to open it. It's very good for organizations, especially who care about security. And oh no, it's this one. This one for your workspace that you're not able. But this one particular, uh, all your clusters, because if you watch my Model 5 about, I talk a bit about networking, that you usually have your network in the cloud and you split it by subnets. But each subnet might be private or public. Public, it means if any resource deployed in your public subnet, it's accessible through the internet and you don't need to configure anything. maybe only firewall to open the ports. But if it's private subnet, it means it's not available in the internet. And then you need to do a lot of configurations to make other resources access it. So this configuration, no public IP, it means if I will create the cluster, so what is cluster? It's just a virtual machine. In my network, this cluster won't be accessible to the internet. This cluster won't able to read my JSON file that I will upload to the storage. And in Azure specifically, they have the things like private endpoints and private links. This is the way how you can take different resources and make them connect each other without going to the internet. So like internally in data center or like in Azure infrastructure, so for security. And I always have troubles how to configure this thing, but this is kind of like best practices for the production Azure resources, this networking. Not much about this, but this takes time to understand. So I will put no here. Yeah, encryption, I don't know, maybe I think it's having something by default. This one I never use. Tagging, review, and create. So if everything good, it will take some time to create. But very good thing right now with Databricks, you can use the free version, the one that Vlad used, and it doesn't. It has all the features we need.
Yeah, it's really convenient because I think they didn't have it previously, right?
No, they just recently announced this
Yeah.
thing. So what's now happening? Databricks is provisioning everything, and what I want to show also, because this presentations I did specifically for Microsoft, talking about difference between Databricks and Synapse. And obviously right now Synapse moving to Fabric, but the product's still the same because in Synapse or Fabric you have this lakehouse, or you can have a kind of like dedicated pool. Maybe the Fabric is still available. It's like your Redshift warehouse. Then you have Synapse Spark. This is your Spark clusters, and then you have serverless SQL. So just the SQL endpoint, and they all can reading your data storage. And then in Azure, you have Azure products like Azure DevOps. This is repos, your pipeline. So it's the same as the GitHub and GitHub Actions. The Power BI for reporting, Azure Data Explorer. This is more like Splunk or Elasticsearch, where you can store a bunch of logs and quickly query them. Data Factory for orchestration. And by the way, next week, I'm planning to do the projects where we're going to build some kind of Azure data warehouse. And I want to use AI as much as possible to build it for me. So again, I will act as an architect, giving the instruction to AI, and AI will not telling me what to do, but actually do. So I will use Azure CLI to be able to do all kinds of things for me. So create resources in Azure, create the documentations, and basically idea will be simple. We will set up some backend database and then something for data warehouse, and we'll trying to create data factory and load data from one place to another and do some kind of transformations only using AI. Okay, and integration, this VNet, same as VPC in the AWS. The streaming solution in Azure is Event Hub. Azure Machine Learning. Key Vault is where I store the secrets. In Databricks, it's a kind of like, it's not only compute, because this is only like compute. And of course, you have some kind of catalog, but Databricks is not only compute. As you just saw in the Vlad example, it's a lot more. And this is architecture of Databricks. The one thing is to understand about this. It consists from two parts. And I think, Vlad, do you remember how they call it, like control plane, data plane? Yeah, the one is control plane
Yeah,
and another data plane.
and data plane, yeah.
So the control plane, it's basically your workspace. The thing, the UI you have, the button you click there, or serverless clusters, and so on, it's managed by Databricks. So it's hosted inside Databricks, AWS, Azure, Google accounts. But data plane is things that you manage. And this is and then they can talk with each other. And then in terms of those network configurations, if we say no public access for our workspace, it means this control plane, this web UI, will be hidden from the internet. And then if you tell your cluster no public IP, it means inside your VNet it will hide. But if you hide your workspace, you need to do a bunch of work with, I don't know, private links and some kind configurations to make sure you can access it and open. And this is probably another diagram of the same. Now is it? Yeah, it's kind of what is in manage account hiding from you, and this is what you control with all kind of services. So, and Synapse still not really well as a product, and I don't know, I didn't hear anything about Fabric yet. Okay, let's go and see. Yeah, it's done, and we can see what we have. So this is our workspace. We can see we have one resource group that it's my resource group, but we have managed resource group. And we can open the manage and see what kind of resources has managed. So the managed resource groups, it means those resources were created. They were probably created in all, not probably, they all created in my account, but I don't have access to them. So you see the storage account. This is DBFS. This one was created by Databricks for internal storage. Unity Catalog Access Connector. I even don't know what is it. It create the virtual network, VNet. I think it will spin up the cluster inside it. So it create the security group. It create the managed identity. So managed identity in Azure is similar, like IAM role in AWS. So you can, it's like service account to grant permissions between services. But if we go, for example, VNet and see what is VNet, you see it has public subnet and private subnet. And this is this private address, and this /16, I think it's CIDR notation. I also covered this in the model 5. This is how in network usually you want to specify the range of IP address. You have two subnets. This is the subnets, and you have they both looks like private for me because 10 point I think, yeah, and this there I'm not really good. But this is a problem, and that's why in AWS or Azure you need to go over solution architecture course because they actually telling you about all those networking best practices. And this is what available in my current my resource group.
And regarding the Unity catalog, I recently had a case where companies somehow, I don't know how, but they deleted Unity catalog. And
from Azure, like maybe this thing, or they deleted. I don't know even how you can delete it.
I have no idea. So it was a weird case, but I think it's still in progress. So they somehow deleted it, but to restore it, of course, they need to get some help from Databricks because it is um, under their management. So
Does it mean the Unity catalog is part of like control plane? It's
yeah.
not your, right? Yeah.
Yeah.
And this probably the Unity catalog access connector. I think this is some kind of like breach that
Yeah, I
can,
think so. Yeah.
yeah, it means it's managed thing. So I'm not sure. I can try to delete after, but usually if it's inside manage resource group, we don't have permissions to kind of come and modify them. So they just creating for us. Okay. Um, now we can launch workspace. We have one of the really nice project on Databricks that Dmitry Anoshin showed us. This is how they develop in Databricks. So they use only VS Code to write the Python code and everything, and then they will create the wheel package. So wheel package is like you can write your Python code or Python applications and basically put it into wheel package, and then you deploy wheel package into Databricks cluster. So it means you're using Databricks cluster, but your cluster running your custom written Python code is a wheel package. So it's a bit weird situation, but it worked interesting, and yeah, he covered really well in the project. It's in YouTube. So here, yeah, we come to here. It's the new workspace. And the first thing I can do, because I have hybrid now, I can create warehouse, and we have all-purpose compute and SQL warehouse. So SQL warehouse only to write the SQL queries, and they have by default the serverless warehouse, but we can create another SQL warehouse. So it's still the same virtual machine, but specifically to write SQL. All-purpose compute, I can create the cluster, and I can give the name. I can apply some policy. I don't know, what does it mean? Personal power shared, compute legacy.
Usually it's unrestricted, and that's enough.
Yeah, then it's a policy. Personal, you see it's just one. I don't need machine learning. It's just one. But if I will say power compute, it's not one machine. It's actually give me. So what we have here, we have um, uh, the Databricks runtime. So, and it has version of the Spark. You see, like this is the 4.1 or 3.5, because different version of Spark have different features. So this is the most recent one. Do you remember what does mean LTS?
No, actually, I don't remember. I remember that it may be related with libraries, but not sure.
Yeah, let me check with AI. Long-term support. Oh, it's kind of like still supporting. It means because obviously the fresh, so this one doesn't have support like, but this one supports, or like this one LTS is kind of like the last version per release, and it has support. Okay. Yeah, and then because you have your worker type, and usually I think before we can choose the worker type and the master type, but now I can see it's only worker type. Maybe master will be automatically added. Photon acceleration, it's to make, I don't know, better query planning. So the cost of Databricks is not in dollars, it's in Databricks units, and then you can convert them into actual money. So here we can choose the type of the virtual machine. And yeah, let's go to personal one, and I can choose any of them. And we have termination. Same with Snowflake. Like if the cluster is inactive, it will go down. For advanced, we can, because it's virtual machine cluster Spark, we can pass any parameters we want. And this is where challenge starting appearing with then you running your cluster with Spark, because you need to do something here, and it's yeah, not good. And even by default Spark, then it's starting already Databricks tuning it, because that's the difference between open source. It has some kind pre-tuning things. Logging, we can save logs if you want, generate our cluster. And additionally, we can add init script For example, you want that the cluster starts because by default, my cluster won't able to connect my blob storage or anything resources. So I need to configure it. One way of configure it, we can open notebook, run a couple commands, and my session will have connection to the storage account, for example. Or we can configure it here. Or I can pass here parameters. For example, if I'm using this service principal, it has a access key, like secret key, and I can pass it here. It means then cluster started. By default, it has write access to the external blob storage. And we can see in JSON how it looks like. And the same like we had Terraform for Snowflake, we can have Terraform for Databricks as well. Okay, I click create. So it will take some time probably to create the cluster. What else we have here? This is Unity catalog. It has some samples. The legacy Hive. And maybe if I go to SQL editor, I can start new SQL query. And this is more like analyst interface. So same Vlad did. And we can try to, so we have samples and it's Delta shared. So it's basically same idea as Snowflake sharing. So you can share between someone has data and want to share with everyone else. So you can create shares. And see if it's gonna work. So yeah, it will use the SQL warehouse, but also, I don't know, it has lake-based Postgres. I think if you know this, last year Databricks was acquired, I think Neon. This is the Postgres database vendor. And Snowflake also acquired some kind of Postgres database. The idea that you not only have analytical workloads, but you can build the whole backend systems like OLTP inside their platform. So we attach and run. So now it's querying some kind of data. Yeah. And if I want to connect Power BI or any BI, so I need to, I don't know, maybe use the serverless cluster, or if I go, but just to also show the difference, this is typical SQL. And what is this? In the past, Databricks acquired Redash. So Redash is same as a Metabase. It's your open source BI, I think, and they acquired it and integrated into this interface. So it's basically Redash. If I go here, SQL warehouse, so I have my warehouse running, and I have connection details. So, and this is how you're gonna connect like dbt, Tableau, Power BI, or something else. You basically copy those like credential things from here. Depends what you need. So we have monitoring, so how long it's running and what it's doing. But we can go in workspace and I can create new notebook. And here you see it's understand, oh, it's use magic command SQL, so, but it can use serverless cluster or my Surfalytics still running. So here I can decide what cluster I want to use, or even I can use the SQL warehouse. So it's they don't call the same, but they can split differently. And now I use another serverless cluster. But let me change this. This query to have a kind like in pyspark command. So if this is SQL command that's still running, This one is a Python. You see, it's Python. So this is how typical traditional Spark used to work. We can reference the table, right? We can read and create data frame. So if I will just running right now, nothing will happen. It will instantly finish because it's kind of like more or less transformation. So it's create the data frame, this abstraction on top of this table. But now, if we want to call it and show template, then it will actually reading the data. So it's how it returns. What we can do. So, and usually we can read the JSON files, whatever files, and then we create new table here, or because Databricks often works in the way you have medallion architecture. So you have bronze, silver, gold, and you're probably aware about this in Databricks. What it will means for you in Databricks, assuming you have your workspace or repos, and then you can have multiple folders, like for example, bronze. Then you will have silver, and then gold. Exactly the same as a DBT architecture. And then what you have from here, what it does, here you can create your notebooks with code. I can create, but first I need to integrate it. But the idea, after I have my folder structure, I can start to create files. And usually for bronze and silver, we have pyspark, and for gold, we have SQL. Yeah, and this is how you structure. So if you want to run any projects on Databricks, so you can spin up everything and then better integrate external storage, not using the built one. And the second, you connect real GitHub, and then you, whatever project you built in DBT, you can try to build it in the in Databricks. So job and pipelines, if you assuming have some transformation jobs, you can schedule it here. You can create the job. It's like cron scheduler that will executing the notebooks. But also they have things that calls, I think, DLT, and they maybe lakehouse something. Vlad, do you remember how they call it now? Then you have DLT pipelines, those YAML files definitions.
They put it somewhere, but I don't remember where it is right now. Yeah, but it was there.
Orchestrate jobs. So, but the idea, they have their own orchestration framework that you don't need Airflow. It has the same DAG, and you use YAML files to describe what execute and how execute. But also, you see, they have new things like data ingestion, and this is probably built-in connectors. Not that many, like you might have in Phytron. But for example, you can access Google Analytics, ServiceNow, Workday, very few of them. Or Phytron Connect. Maybe it's, through the partner connect, you can access many of them. But Phytron actually will just, you create the Delta Lake or Delta table, and it will write it. And I think another important thing to highlight, those tables, they kind of Delta tables. So, and they Delta tables, but then you have Delta table, you have two options. You can have manage Delta table. It means you have the table and Spark write and read this table, but you have no idea where is the data. So the data obviously in your storage, but it has weird path, like some kind encoding code string. This is the path to the data storing. But then you have external table, so you actually control where the data is storing. And obviously it has a lot of things for AI. So it has playground for some, so you can use something to start prompting and using model. Then you can have the agents. You can run experiments. It has ML flow it's ML ops things, like if you want to have like your host your models, machine learning. Features is probably about feature store. You have models, so you can create the model. Oh, here you can use the model. For example, if you do some kind of RAG system and then you need model for encoding data like JSON files to create vector database, so you can use the register model as an endpoint and doing this. This is I learned in generative AI training on Databricks and serving. So those the models are available in Databricks as an endpoint, and you can use them. But I'm out of use cases. That's about it. But for you, for data analytics use case, you just need to think about, yeah, you have your different folders, bronze, gold, silver, the data storing in outside storage. So you start reading the data and save into actual like tables in Unity catalog, because you will have the same schemas. You will have schema bronze, schema silver, schema gold, exactly the same as a DBT. But instead of your DBT model SQL, you might have PySpark or SQL files, and then you can run them with jobs or pipelines inside here or trigger outside of Data Factory. Yeah, that's it about it. Yeah, if you have any question.
Yeah, and one small notification that usually when you're working in Databricks, you have to work in Git repo in terms of your jobs and notebooks, and after that you can create tables in Databricks, because otherwise it will be inconsistent. So it's more regarding the CI/CD feature.
Yeah. And Jenny, I think it's some kind like assistant on your data. But you say you probably can create the semantic layer here to chat with your data, and you can have create the dashboards. This is just example, but it's used the same with Dash capability. So you can query data and build the dashboard. So you have the whole platform. That's why some teams who is using Databricks, they can do anything here. And they're both machine learning, data science teams using the same. Snowflake gives you the same capabilities, but still people don't feel comfortable running machine learning workflows in Snowflake. Aijan, did you have a question?
Yeah. So I guess I have specific question regarding my current projects. So if we choose Databricks as a warehouse platform, how the data ingestion can be set up between Oracle and Databricks? I'm not sure like Oracle is in on-premise or cloud, but if you can.
Doesn't really matter, because first thing you can check is come to here and see, does it have any active connector for Oracle database? If not, then what you're doing, you, for example, I'm going to here and I create new notebook, assuming in the bronze, and let me share example. Like any other database. So the benefit of Databricks, because you have the code, so you can write the code to do anything for you. So it's doesn't have any real control. So this is example. You have JDBC connection, the same like from DBeaver or BI, user password or maybe another way connecting it. And then you can have this is straightforward way. So you can have, oh yeah, I want to connect table, and then you read, so you can use your connection, right? And this is your connection. So you define your connection, use your connection, you specify the table, and Databricks can read your table. And then you can also probably passing some kind of filters, you reading and moving it. But I think for my project where I currently work, they also have the use case to move Oracle to Azure. Do you work in Azure?
Yes, so currently we're considering like Fabric or maybe go with Databricks. So yeah, I have like experience with Fabric, but it has a lot of limitations, Fabric. So I was thinking about Databricks, but does
Yeah,
it
Databricks definitely has less limitations for you.
have limitations? Okay.
It's telling me that okay, what I asked this question AI, so using Azure Data Factory, but okay, one option is using Databricks Partner Connect with Fivetran or another tool. Another thing, Azure Data Migration Service. It tells me about this one.
Also, you mentioned about the cluster setup, right, for Databricks. You said it's
Yes.
painful. Yeah, I have to know like details.
This is you just use serverless. That's it. No,
Serverless. Okay.
yeah, you don't need to overcome. Yeah, this is Azure Databricks Migration Service. I think this service is similar to DMS in AWS. So here you can choose Oracle.
Migrations.
But I think this is not good example because it's only target use SQL Server. So you don't want to have. What's about others? If I use, yeah, no, I don't like this one. Oh, I see. What it tells me, one case, I don't know how it's good. It's telling you, you do migration to the Azure. So you pull the data from Oracle to the Azure cloud and Azure instance automatically. And then you have a direct connection between Databricks and Azure SQL.
Yeah, got it.
Yeah, that might work. And you will focus. So the data automatically will sync between Oracle and Azure cloud, but then you only control Azure SQL to Databricks.
Yeah, makes sense. Okay.
Yeah, but otherwise, yeah, the straightforward was the GBC connector, but it might be performance-wise, I'm not sure what's gonna happen.
Got it. Okay, great. Thank you so much.
Yeah. Yeah, so the plan is simple. You first learn dbt Snowflake, Fivetran to just understand, and then you can do exactly the same in Databricks. So there are in data engineering or like in industry only two distinct platforms. It's Databricks and Snowflake. Yeah, because everything else more or less in Snowflake, and it means you can use the same patterns with dbt. With Databricks, you can use dbt, but it's not that friendly. It has own patterns. Okay, everyone. Yeah, Vlad, you can share the record and we can decide do you want to split into two or keep one. Let me know whatever works for you.
Yeah, thank you everyone. Yeah, I will share the record soon. Yeah.
Okay, bye everyone.
Yeah.
Thank you.
Thank you. Bye bye.
Bye.